Alright, I'm going to try to do this again without a graphing calculator because a lot of you don't have it. Alright, so if I graph this, f of x equals 2x, I'm going to get a graph that is pretty steep. It's going to look something like that. But if I graph f of x equals 6x, now my slope has gone from 2 to 6. I'm going to get a graph that's extremely steep, right? So how are they the same? Well, they have the same b's, same y-intercept, right? Same y-intercept. How are they different? They have different slopes, right? So as m increases, the graph becomes more steep or steeper, right? Steeper is probably a better word. Then we come down here and look, those are fractional graphs. So I will show you what these graphs would look like, right? If I graphed f of x equals, instead of writing 0.5, I'm going to say 1/2 x. I'm going to graph that looks somewhat unsteep like this. But 2/10, if I'm going to graph that, f of x equals 1/5 x, I'm going to get something that looks really flat, much less steep than this, right? So as m decreases, the graph is less steep, and decreases towards 0 anyway. So there's one thing, and it makes sense, right? The slope gets larger, we can become more steep. The slope gets really small, less steep. So really there's just two concepts. B moves us up and down, right? And the slope, right? Big steep slopes, high slopes make us steep. And as I approach almost 0, I'm just above a 0 slope, very less steep. What happens when we do a negative, right? What happens if I said, hey, let's compare m equals x, which looks like this, right, to m equals negative x, which looks like this? What happens when a positive slope turns into a negative slope? Well, right, this graph versus this graph, they have the same y-intercepts, but one has a slope of -1, right? And what that is, it gives me a negative slope. I go down, but it's called a reflection over the x-axis. All right, so write that, and we'll talk about what that is. All right. Now, I'm going to show you a couple things. I'm going to do, let's say y equals -x. I'm going to get a graph that looks like this. Let's say I start to go from -1 to 0. Let's say y equals -1/2 x. Well, that graph is going to still be negative, but it will be much less steep. So as m increases from -1 to 0, it's less steep, right? As m decreases from -1, like if I said y equals, let's do one down here, y equals -3x, I'm going to get a very steep but negative graph right here. There it is. So I want you to have this down. And I'm going to end that page, and we're going to talk just a little bit more about how it works down here. Well, let's do one more. Okay, let's do this page, and then we'll talk. So here's the notes. Write this down, and I'll show you in class this. When m is greater than 1, the graph is stretched vertically. When m is less than 1 but greater than 0, the graph is compressed. And this is probably less easy to see with a line than other functions, but I do want you to have this note, right? And then we're going to get this function family down here, and I'll do one last video. I realize I'm going kind of fast, and it's a little out of context. We're going to have to fill this in when we talk in class. This is a really hard lesson to do without calculators. So this is a parent function that talks about all linear functions, right? That means the simplest linear function ever is a parent function, f of x, slope 1, y-intercept is 0, and it's a linear function, right? The most basic parent function is f of x equals x, or we could say y equals x. That means nothing's been added to it. And then the parameters we talked that change things, right? M is slope, b is y-intercept. B moves me up or down. M makes me steeper or less steep. That's what they do. And we're going to end this right now. I know that's quick. We will fill stuff in. Talk to you later.